The goal of this video is to give a basic introduction to working with composites. After watching this video, you should be able to perform basic manufacturing using composite materials. In this video, we will cover the manufacturing of a close-up panel that will be used on the floor of the Formula car. The beginning to any composite project is the mold, often referred to as the tool surface. This is the critical surface of your design, meaning this is the surface whose finish and/or dimensions you care about. The preparation for the mold is an entirely different process that can be very simple or complex. A summarized explanation is given next. The mold that is used in the video is constructed from a melamine wood panel and a 3D printed solid. Significant time was spent working on the surface of the mold using fillers and various sandpaper grits to get the mold to the necessary smoothness. The target feel and look of a finished mold should be as close to glass as possible. When working with melamine panels, be careful not to sand past the covering and expose the wood fibers, as those will break the seal of the vacuum. Be sure to leave plenty of extra space around your desired product for all the material and cloth that will be used during the layout process. Once your mold has the desired surface conditions, you will need to apply a release agent. There are many different products that can accomplish this. On our more complex molds that are made out of more chemically resistant materials, we use products from Chemlease, such as their 41EZ or their PMR release agent. On some mold surfaces, a sealant must first be used to close out any porosity in the material before applying the release agents. As you can see by the green appearance in this mold, the release agent used in this case was various coats of PVA. This is a water-soluble, plastic-like coating that can be easily applied and cleaned off when finished. However, the reason why PVA was chosen in this case is the lack of strong chemicals in the substance. Due to the 3D printed surface, any chemicals in the other release agents would most likely affect the plastic and negatively affect our finished surface. The release agent is one of the most crucial things in this process, as it is what allows the cured component to separate from the finished mold surface. This is accomplished by creating a physical barrier with poor adhesion properties for the uncured bonding material or matrix to adhere to. If this step is skipped or rushed, meaning not enough coats or not enough time between coats, it is very likely that the final component will not separate from the mold, and damage or total loss will happen to both parts. The last step in mold preparation is to place down the tacky tape used to form the seal between the mold surface and the vacuum bag. When placing down this tape, it is best to do it before any wet epoxy can be spilled on the surface, which can prevent a good seal from forming between the surface and the tape. Be sure to press down firmly on the tape, especially over any locations where the tape joins other strips of tape. The cheapest and most DIY version of performing a composite layup is to do a wet layup procedure at atmospheric pressure. By cheapest, I don't mean that the quality or performance of the product will be bad. If you want to see a great project that is mostly done this way, head over to Mike Patey on YouTube and follow his build on Scrappy to see how much you can do using this method. To begin this method, cut out a sheet of plastic where you can spread the epoxy without making too much of a mess. When mixing epoxy, be sure to use a square-tipped stir stick. This will allow you to scrape the edge of the bottom of the cup and truly mix all the substance. As you stir the epoxy, you will notice that the unmixed epoxy can be seen by the streaking pattern created by the hardener. When all of the streaking has disappeared, you can determine that your epoxy is fully mixed. Be gentle with your mixing speed and motion to avoid trapping or creating many air bubbles within your mixture. Trapped air bubbles will create porosity in your final component and will negatively affect its finish and performance. Keep in mind that epoxy will have different mixing ratios, whether by weight or by volume. If this ratio is not accurately followed, the resulting matrix will fail. Always read the specified directions on your epoxy datasheet. Having a homogeneous mixture, you can begin wetting the fibers. Lay the first layer of fabric on the plastic and pour some epoxy over it. Having done that, fold the plastic and begin spreading the epoxy with the squeegee. As you are spreading the epoxy into the layer of fabric, be sure to pay close attention and not miss any dry spots or produce any overly saturated spots. The direction of where and how you push isn't important as long as you spread the epoxy evenly. Be careful not to press too hard as to distort the fibers. The goal of this process is to saturate the fibers and then remove any extra epoxy that can be removed by the squeegee. Oversaturation doesn't mean a stronger result. If anything, it's more likely to make a more brittle and heavier final product. If you look here, you can see how a dry spot within the fiber looks like. Be sure to cover the entire area of your material before moving on to the next layer. Once you are satisfied with the appearance of your fabric, you can introduce the following layer. To do this, open the plastic while holding down your material. Be careful of fibers that can be stuck to the top layer of the plastic, as they will most likely distort the weave if they are pulled. For the next layer, simply drop it in place and pour some more epoxy over it. Repeat the same process used for the first layer to spread out the epoxy. Having fully wet out both layers of fabrics, you can push all of your extra epoxy out of the way with a squeegee by using a little more force than you were using before. Not only does this remove any extra epoxy and produces a lighter product, it also aids in removing any trapped air bubbles from within the fibers. After the second layer, be extra careful when pulling the plastic apart, as the topmost layer can adhere to the plastic and peel off your wet laminate. Having completed the amount of layers desired, you can remove the wet laminate from the plastic and place it on your mold. As you peel off the laminate from the plastic, be mindful of any loose fibers that can become stuck to the plastic and unweave or distort your laminate. Avoid lifting by just one corner, as this will also distort your laminate. Instead, if possible, lift an entire side at a time so that all the fibers carry the force at the same time. When placing on the mold, I suggest adjusting the fibers from the most complex section of the mold out towards the edges. In our case, the most complex section is the top of our mold. Keep in mind that for more complex geometries, the laminate may not be capable of conforming to the shape without the use of relief cuts. If it does become necessary to cut the fibers, be sure to allow for different layers to overlap over the cut, and to cut relief cuts at different locations to allow the fibers to remain uncut at any given section of the laminate. Once you have placed down all of your layers, feel around your mold to see if you can notice any bridging or gaps or folds inside of the laminate that you may not be able to see. All of these will negatively affect the final part of your surface. A tight fit around the mold will produce a geometrically accurate and smooth final product. While you may leave your final product to dry just the way it is now, for improved results you can always attempt to place weights or any form of pressure over it. If doing this, try and use a release film to keep whatever weight you're using from becoming stuck to the laminate by gluing itself to the epoxy. Composite products usually produce better results when used with two-sided molds and are subject to pressures during curing. These pressures allow for a tighter fit around the mold, and they also help with removing any air or gases from within the product. This is the most common process in professional applications.
For this procedure, you can follow the same steps as when creating an atmospheric pressure layup. However, due to the vacuum bagging, you also have the convenience of wetting the fibers directly on the mold by dabbing epoxy with a paintbrush to tack the fabric to the mold. Due to the vacuum bagging, the pressure exerted on the part will remove any excess epoxy away from the fiber and prevent it from staying in the final product. Just like explained previously, this process is also easier when starting at the most complex part of the mold and moving outwards. Quick tip: before you start dabbing the epoxy, make sure to do your best to get any loose hairs off your paintbrush to avoid having any contaminants in your layup. After dabbing the entire area, you can add another layer by simply placing the dry fabric on top and repeating the process. The materials needed for the next step must be prepared at least before you begin mixing the epoxy and wetting the fibers. However, it's best if done before even preparing the mold to avoid possibly affecting our release coat. These raw materials need to be cut and sized to our mold to verify proper fitment. Depending on the size and complexity of the mold, this step can take too long, and if done after mixing the epoxy, it will result in having a partially dried product by the time you finish the vacuuming process. The first material is called a release film. The release film is a thin film that is engineered to prevent it from bonding with the epoxy. This film is usually capable of transporting epoxy and air through the film into the bleeder. In our case, our release film is covered with many little holes and it is referred to as a perforated film. There are other types of release films depending on how much epoxy you want to flow through or the finish that you want your final product to have. The next film is the bleeder, and its purpose is to allow both air and gas to travel from any location in the layup onto the vacuum port to be sucked out, as well as absorbing any of the excess epoxy that travels through the release film. In a complex layup, these two functions will need to be separated into two different layers of material, since the absorption of the excess resin will begin to impede the flow of gases. Finally, the last material is the vacuum bag. The vacuum bag is the barrier that allows a seal to be formed with the sealant tape. It is always recommended to have an oversized vacuum bag to allow for any unforeseen deformations that could cause a fitted size to no longer reach the other side of the mold. Just like the release film, there are various types of vacuum bags that allow them to adapt to the project they are being used on. Moving back to the layup, we begin by placing the release film down. If necessary, cut any relief cuts into the release film to allow the film to sit flush and as close to the fiber as possible. Any wrinkles in this layer have a high chance of passing on to the final component once this is cured. The film must cover all areas of the epoxy to avoid having the bleeder attaching itself to the final product. Pay close attention to the borders and your tacky tape to ensure that no loose fibers are going to interfere with the vacuum seal. Next is the bleeder. When placing the bleeder, avoid any exposed areas. If needed, cut some scraps of release film to place under it. The bleeder must be sized to cover the entire area of the layup. Our next step is the vacuum bag. However, before we place down the vacuum bag, we must first place down the vacuum port. When placing down the vacuum port, be sure to place an extra couple of layers of bleeder underneath to give it more cushion and preventing it from sealing itself to the mold. This is also to protect the valve from being contaminated with epoxy if there is an excess of epoxy in the area where it is placed down. Do not place the vacuum port over the final product. Having placed all your films, you may now begin to stick the vacuum bag onto the tacky tape. Begin by peeling one side of the tape and sticking the bag as close to the edge as possible. After this, you can move around the mold as you see fit. In this case, I will stick both sides of the bag first, and then close the last side opposite to the first side. During this process, have a few short strands of tacky tape ready. This is in case you need to form any cleats. As you can see, my last side has a longer bag than the available tape. To get the bag to fit properly around the mold, a cleat must be placed. This is done by placing the short strand of tacky tape on top of the tacky tape that is already present, to form a vertical portion of the seal. As the bag travels around the tape, the excess bag is consumed, which allows you to seal the mold. This technique can be used unintentionally, as shown here, or strategically when performing complex shapes. By adding cleats around the mold, extra bag is allowed to remain over the center, which will be used to adapt to the geometric changes. Once you are satisfied with the appearance of the seal between the tacky tape and the bag, you may cut a small hole over the vacuum port with some scissors. This will allow for the top portion of the vacuum port to connect with the lower portion. When joining the two halves of the vacuum port, be sure that no wrinkles from the bag are trapped in between. These wrinkles will create vacuum leaks that become very hard to find. To ensure a perfect seal, firmly twist the top half to seal with the bottom. You are now ready to connect the vacuum to your mold. Do this by pulling the quick release handle from the hose and connect it to your mold. As you can see, the vacuum pressure pulls the fabrics down tightly over the mold. The resin begins to travel through the release film and begins soaking the bleeder. Be sure to feel around your mold to make sure that the vacuum bag is tightly wrapped around the mold and that no bridging or any form of gap is formed in between the mold and the fabrics. Lastly, you can check your seal by listening for any leaks. If no leaks are audible, you can double check your vacuum by using a vacuum gauge connected to your system. In our case, our vacuum gauge is showing 24 inches of mercury, which is the correct reference value for our system. After double checking all aspects of our procedure, we can leave our part to complete its curing process. After leaving your component to complete its cure cycle, you can unbag the final product. To begin, you must first disconnect the vacuum hose and remove the top portion of the vacuum port. You can then proceed to remove the vacuum bag. Do this by firmly tugging on the vacuum bag to unstick it from the tape. It doesn't matter if the tape stays stuck to the bag or to the mold. Most often, the bleeder will adhere itself to the vacuum bag and will also peel off from the final product. Once you remove the vacuum bag, be extra careful to remember to remove the lower half of the vacuum port from your waste material before you dispose of them. Sometimes the release film will stay glued to the final product. If it stays behind, you can simply peel it off from the final product. Depending on the film, these can peel right off or begin to rip as you see here. It is easiest to remove the film as one, so if it begins to rip, try to begin from another corner. We can now move on to removing the final product from the mold. If the release agent was correctly applied to the mold, the final product should just pop off after some effort. This process is easiest with some tools like plastic stir stick or plastic prying tools. Avoid using any metal tools such as screwdrivers or pry bars, as these will most likely scratch both your final product and your mold. This is especially important if your mold will be used more than once. During this process, be extra careful with your fingers and your knuckles, as dried carbon can be extremely sharp and will cut through your skin before you realize it.
Always pry all of the edges first to debond them from the mold. Just keep working around the mold and attempting to pry it off until it just pops off. Don't use too much force as to break your laminate by bending it too much. At some point, the mold will just simply pop off. On this example, the mold was waxed before the PVA layer was applied. You can see the layer of PVA that separated the wet carbon fiber and the wax on the mold as the part cured. If you use PVA and you can't peel it off as shown here, you can also remove it by rubbing a wet paper towel against your final product or your mold to dissolve it. Your final product is now ready to be moved to post-processing, where it can be machined, cut and trimmed, and sanded to its final fit and finish. These are all of the basic concepts and skills that you need to know to perform a wet layup procedure at either ambient temperature and pressure or under vacuum. Thank you for watching.